Hello, is anybody there? I don't see anybody.
Press star to create a new conference.
Hey, are y'all here to take my math class?
We are
Y'all
not.
want to take college algebra?
I got that eighth period.
Oh, you already got that done. All right. Well, I guess we can get started. You're doing English, I bet, right?
Yes, sir.
Yes, we should be in English, but I don't know
Oh,
what is going on.
I think they're trying to get everybody. Oh, and there's my Lorenzo class. Hey, how are y'all? All right, is this English? Well, I guess we're trading. I guess we're doing. What is that? Musical chairs. We're trading places today. English. What are we doing? Like diagramming sentences, nouns and pronouns and adverbs. Uh, Let me see what I can go do. All right. Hi there, student. How are y'all? Okay. Is anybody else here? I don't. My camera isn't set up the way it used to be.
Post is here.
Hey, Post. How are y'all today?
We're good, I guess.
Planes is here.
And Plains, hi Plains. Yeah, they had some trouble getting things set up for us this morning. Um, all right, today is the 25th. All right. So we are now in week 9. I have not finished grading the exams, but I should get those done tomorrow and get those grades posted before class on Wednesday. I'm expecting really good results. I've got about almost 50% graded, and I mean, for the most part, everybody's doing really good. So we'll get the rest of it. I'll get the rest of that graded, and we'll talk about those graded exams on Wednesday. So this week is, I guess you could sum it up as we're kind of wrapping up our graphing section of this course. So this week we're going to be talking about how to graph polynomial functions. We talked about how to graph quadratic functions that form these nice symmetric parabolas that can either open up or down. We're going to be talking this week how to graph polynomial functions that have multiple turning points, more than two or more turning points, and then we'll get started talking about on Friday rational functions. And I've reserved Friday and next Monday to talk about rational functions, as that's kind of, there's a lot of stuff going on in that. But today we're going to really talk about what are called the roots or the zeros of polynomial functions. Basically, this is kind of a way to get a factored form of a polynomial function and know what the zeros are. And y'all have had access to these videos, by the way. I don't know how many of y'all looked ahead, but the videos for Assignment 15 were updated at some point last week. So I got those fixed. Anyways, roots of polynomial functions, Assignment 14. Let's start off with, are there any questions over this assignment, things that we want to look at? I'll be glad to go over.
Can we go over number 7?
Number 7. Yes, we can. Okay. So this is Assignment 14. Problem number 7. We want to, alright, let's begin with our function f of x is equal to a 2x to the third plus a 6x squared plus 5x plus 2. And the first thing that it's asked us to do is to list the possible rational zeros. So I call that PRZ, because I just don't want to write it out. List the possible rational zeros. So, to do this, you're going to list the factors of your constant. So that's going to be 2. So I kind of need to highlight things here because we don't want to get the 2's mixed up. We're talking about that 2 right there. Factors of your constant divided by the factors of your leading coefficients, LC. And that's also going to be 2. So I'm going to just highlight things so we don't get these, so we know what 2 I'm referring to. Alright, so factors of 2, yeah, you got 1 and 2, but you also have to consider the fact that you can have the negatives of these values. And then you're going to go through and divide. So 1 divided by 1 is 1. 1 divided by 2 is a half. Then 2 divided by 1 is 2. And then 2 divided by 2 is still 1, so we've already got that. So there's your possible rational zeros. Alright, so I take it that you probably got that far. Did you find a actual zero of the function to the person that asked this question?
No, sir.
Okay, so this is one of those problems where you just got to start going through the work. And I know I approached a couple of these on the notes where you start trying stuff and doesn't work out. Well, just keep your head up and keep going. So I'm going to start off with 1. Let's just do this for practice. So we're testing whether or not x equals 1 is a 0. And we're using synthetic division to get there. Now, notice that all of these are positive. And here's what's going to happen. Since all of these are positive, things are just going to start piling up on top of each other. The number that we get here is just going to get bigger and bigger and bigger. Observe. Bring down the 2. 2 times 1 is 2. Add, you get a positive 8. Times 1 is 8. Add is a 13. Times 1 is 13. Add, you get 15. That is not equal to 0. So, when it comes to, possible rational zeros, I'm just going to go ahead and omit the positive 2 as well, because that's going to snowball. The 1/2, yeah, it's probably going to snowball as well. We may have to try 1/2, but let's see. The next possibility is x equals -1. Bring another 2, so 2 times -1 is a -2. Add, and we get 4. Times -1 is a -4. Add, and we get 1. Times a -1 is a -1. Add, you get 1. Still not equal to 0. So, because I like whole numbers, I may just bypass this 1/2 just for a moment. Let's see what we can do with 2. I've already said that 2 is not going to work. Because if you plug in 2 here, these numbers are just going to start getting bigger and bigger and bigger. So what if you try -2? 2, 6, 5, 2. So 2 times -2 is a -4. Add, you get 2. Times the -2, or times -2 is another -4. Add, you get 1. Times -2 is -2. Add, you get 0. Yay! This equals 0. Alright. So, this means 2 things. Number 1, this means that x equals -2 is a 0 of f of x. And the second thing that this means is that x plus 2 is a factor. Now, why is it x plus 2? Well, if you take x plus 2 and set it equal to 0, you get x equals negative 2. And what I like to do from here is I like to just take a moment to rewrite f of x. F of x is now equal to x plus 2 times, and remember that when you divide, if this was x to the third, we drop a degree. These are now the coefficients of your quotient of what you get after synthetic division. So we can just put those right here and have a 2x squared plus 2x plus 1. Now, use synthetic division, find the actual root, and then use the quotient of the remaining roots to find the remaining roots and solve the equation. So what we need to do now is we need to take this equation, we need to think about setting it equal to 0 and solving. Now, already if I look at this, if I think about factoring using the AC method, so remember AC method is what are the factors of AC that sum to B? Well, AC is 2 times 1, that's 2. That sum to B, which is 2, what are the things that multiply together to give me 2, but add together to give me 2? Well, there's nothing that works. There are no factors of 2 that add up to, at least not factors that we can come up with easily in our head. So, how we're going to solve this? Well, I would probably solve using the quadratic formula. So, A is equal to 2, B is equal to 2, and C is equal to 1. So we have x is equal to the opposite of B, plus or minus the square root of B squared minus 4 times A times C, all over 2 times A. So, here's what we want to evaluate. Negative 2 plus or minus the square root of 4 minus 8 all over 2. So it becomes negative 2 plus or minus the square root of negative 4 all over 2. So negative 4, the square root of negative 4 is a 2i. And now we can divide everything by 2. So this 2 gets divided by 2, this 2 gets divided by 2, and we get negative 1 plus or minus I.
Isn't there supposed to be 4 at the bottom?
Oh, yeah, went too fast. Let's back up. Okay. 4. Alright, so we still can divide everything through by, basically, think about just simplifying this, and you get, negative 1 plus or minus I over 2. So, let's put everything back together. Here are our zeros. X equals negative 2, and we have x is equal to the negative 1 plus or minus I over 2. So, if I were to list off my zeros, I would say x is equal to negative 2. X is equal to negative 1 minus I over 2, and then x is equal to negative 1 plus I over 2. Alright, does that help with number 7?
Yes, sir. Thank you.
So, I'll just say this, all of these problems, you can eventually find a actual zero using the synthetic division. But, you know, it may take you some work to get there. And I would be thinking about your coefficients, like for the fact that since all of these are positive, we had this snowballing effect right here. These numbers just got bigger and bigger. So I wouldn't plug in any, once I realized this, I probably wouldn't test any positive number. That's why I skipped x equals positive 2. I didn't even try it. I would also be very, what's the word I want to use? Systematic. Don't skip around. Start off with doing positive 1, negative 1. You may want to skip the fraction for a second and just go to the integer one, positive 2, negative 2, then maybe if there's a positive 3, negative 3. You want to be very systematic. Don't just randomly pick one of these up here because you may end up hitting or missing that 0. You may end up spending a lot more work. The other thing I want to say is it's very much, you got to make sure that your arithmetic is correct with the synthetic division, because if your arithmetic is off, we know that x equals negative 2 is a 0, but if your arithmetic is off, you may find that your arithmetic may show that it's actually not a 0. So be very careful. Alright, what else can we look at? It's a really rather short homework assignment. Anything else we can look at? Any other homework questions?
Can we do number 14?
Was that 17?
14?
14. Alright, good review problem. Alright, so this equation has a square root, and what we're going to do to get rid of that square root is, if you have the square root of u is equal to d, then we're going to square both sides to get that u is equal to d squared. That's how we're going to get rid of the square root. Now, the first thing that you have to do is you have to think about isolating the square root. Isolate the square root first. So we'll do that by subtracting 5 on both sides. And now we'll go through and we'll square both sides. So over here on the left, the exponent of 2 and the radical, the square root, cancel each other out. On the right, make sure that you write this out as x minus 5 times x minus 5. The number one mistake that I see here is students will write x squared minus 5 squared. And that is not what x minus 5 quantity squared is. When you FOIL this out, you get x squared minus 5x minus 5x plus 25. And you see now that we have this middle term of a minus 10x. And now what we have is we have a quadratic equation that we need to go through and solve. And so the first thing that we need to do to start solving quadratic equations is set them equal to 0. So I think what we'll do is we'll subtract x on both sides, we'll add 3 on both sides. So we get x squared minus 11x plus 28 is equal to 0. So, again, multiple ways to solve a quadratic equation. My go-to thought is, can I factor this? So are there factors of 28 that add up to a negative 11? So the first factors of 28 that I think of are 4 and 7. Well, 4 plus 7 makes a positive 11. We want a negative 11. So how about I make those a negative 4 and a negative 7? Because negative 4 times the negative 7 will give me my positive 28. Then you can set each factor equal to 0. And then you get x is equal to positive 4 and x is equal to 7. But you got to go through and check. You got to go through and check. We got to check this. We got to verify if both of these problems, both of these values work or just one of them. So I'm just going to come back up here. Well, I guess I need to just rewrite it. We have the square root of x minus 3 plus 5, and I'm just going to go ahead and well, let's just put the x right there. And so let's start off with x equal to 4. So 4 minus 3 is 1 plus 5. That's 1 plus 5, which is 6. That is not equal to 4. So x equal to 4 does not work, because we get a false statement. So let's check our other value of 7. Alright, so let's see. 7 plus minus 3 is 4. Plus 5, that's 2 plus 5, which is 7, which is equal to 7. Check. So x equals 7 does work, and that's our only solution. Okay, does that make sense?
Yes, sir.
Alright, anybody else? I think we're all tired this Monday morning. Number 3. I saw like 3 people yawning at once, and I was yawning with you. Number 3. So number 3, all we're doing is listing the possible rational zeros. List the possible rational zeros. So we start off with what are the factors of our constant. So our constant is negative 3. Factors of negative 3 divided by the factors of our leading coefficient, which is 4. So the factors of 3, we got plus or minus 1, plus or minus 3. The factors of 4, we have plus or minus 1, plus or minus 2, plus or minus 4. And we're going to go through and do some division. So I'm going to highlight to help us keep our head on straight. Let's take the 1 and divide it by 1, divide it by 2, and then we'll divide it by 4. So 1 divided by 1 is 1. Possible rational zeros. And we'll put the plus or minus notation. 1 divided by 2 is going to be a half. And then 1 divided by 4 is going to be a fourth. And then we're going to go through and we'll divide everything through by 3. So 3 divided by 1 is 3. 3 divided by 2 is 3 halves. And 3 divided by 4 is 3/4, plus or minus. And that's it. There's no other values in the numerator that we need to divide with, so we are done. What was your question on number 3? I mean, you said do number 3. Where were you? You mind just telling me what you were struggling with?
I was just confused on the first factor.
Okay. Makes sense now?
Yes, sir.
You're welcome. Alright, what else can we look at? Any other questions? Oh, go ahead. Sorry.
Sorry. How can we do 12 in this class?
12? Ah, yes. Another good review problem. So, this type of problem, I to the 46 power, relies upon basically it's recognizing patterns. And back when we were talking about complex numbers, I did things like this. Let's analyze these values. So, I to the first power is just I. Now, I'm going to remind us real quickly that I squared, remember by definition, is a -1. So I squared is -1. Now, I to the third can be rewritten as I squared times I. Think about adding your exponents together. 2 plus 1 is 3. So remember what is -2? I to the second power, it's -1. Then you're going to multiply that by I, so you just get -I. -I. And then I to the fourth can be rewritten as I squared times I squared, which is -1 times -1, which is positive 1. So, if we can come up with this, then the pattern starts repeating. So, when you do I to the 5th, I to the 6th, I to the 7th, and I to the 8th, we'll start off with I to the 5th. Remember, I to the 5th is the same thing as I to the 4th times I. So 1 times I is I. I to the 6th is the same thing as I to the 5th times I. So that's going to be I squared times I squared, which is going to be negative 1. And this pattern just repeats. This pattern just repeats. So we're going to go I to the 9th, I to the 10th, I to the 11th, and then I to the 12th. We get the same simplified forms of I. So, what I like to do is I like to recognize I to any power of 4 is 1. So, let's get it all the way up to 46. That means I to the 36 is equal to 1. I to the 40th is equal to 1. And then I to the 44th is equal to 1. So I'm just ignoring all this other stuff because I don't need it. I to the 44th is 1, so if I just follow this pattern, that means that I to the 45th is going to be equal to I, and I to the 46th is going to be equal to negative 1. So this pattern that we have here just continues all the way across. So again, the easiest way for me to do this, and I think it might be the easiest way for you to do this, is number one, just know the pattern. Know that I to the first is I squared is negative 1, I to the third is negative I to the fourth is 1, and then we start with I to the fifth, it starts repeating. And also recognize that every single multiple of 4, 8, 12, 16, 20, 24, 26, 32, 36, 40, 44, they all are equal to 1. So if I just continue my pattern, here I'm at 1, then I gotta go to the next two values, I to the 45th, I to the 46th, I get negative 1. So I to the 46th is equal to negative 1. Does that make sense?
Yes, thank you.
You're welcome. Alright, what else can we look at?
Number 11, please.
Number 11. So we'll start off with a list of possible rational zeros. So what are the factors of our constant? Factors of negative 15 divided by the factors of our leading coefficient, which is 1. LC stands for leading coefficient. And this is really nice when it's 1 on the bottom, because all you got to do is just list off the factors of 15. So 1, 3, 5, and 15. Now, when you go through and start doing synthetic division, I hope that you recognize that there is a missing term. We start off with x to the 4th, but then we go to x squared. There is no x to the 3rd. So when we do synthetic division, we have to incorporate, or we have to include this 0x to the 3rd as a placeholder. So when we go through a testing phase, when I solve my coefficients, I have 1, 0, negative 2, negative 16, negative 15. Make sure that you include that 0 for the x to the 3rd. So here we go. 1 times 1 is 1. 0 plus 1 is 1. 1 times 1 is 1. Plus a negative 2 is a negative 1. Times 1 is a negative 1. Add, you get negative 17. And I don't think this is going to do it because, well, that's not going to be 0. Right? What is that? 20, 32? Negative 32 does not equal 0. Alright, so 1 doesn't work, so you keep going. What about x equal to negative 1? 1, 0, negative 2, negative 16, negative 15. You know, we got really close right here. If that would have been a positive 1, well, it would have been nice if this was some form of 15. Let's see if we get it over here. Bring down the 1. Negative 1 times 1 is negative 1. Add, you get negative 1. Negative 1 times negative 1 is a positive 1. Add, you get negative 1. Negative 1 times negative 1 is a positive 1. Add, you get negative 15. Times the negative 1 is a positive 15, and I think we got it. 0 equals 0. Alright, so x is equal to 1. Now, what we want to do now is we want to continue with the synthetic division process. We want to continue with the synthetic division process because what we have here is we have x to the 3rd minus x squared minus x minus 15. And this isn't going to factor by grouping, so we continue with synthetic division. Continue. Now, due to time, because I'm being aware of the time, I always double check this because this could be a repeated 0. So I'm going to continue. I'm just going to start here again, x equal to negative 1, but I'm going to use these coefficients of 1, negative 1, negative 1, negative 15. I always just keep on going because you never know if this is a repeated 0. Now, this isn't going to work. It's not going to give us 0, but let me just take us through this. Negative 1, add, you get negative 2. Then that becomes 2. Add, you get 1, and you can see that we don't get 0. Not going to work. So, this doesn't mean that -1 isn't a zero. It is a zero over here for this polynomial, but not for our quotient. Now, I'm just going to tell you that x equal to 2 and x equal to -2 are not zeros. And I'm only telling you this because of time. They are not zeros. So I'm going to go to x equal to 3. Get 1, 3, add you get 2, 6, add you get 5, times 3 is 15, add you get 0, equals 0. So we have x equals 3 as a 0. And then, with these coefficients, we get the quadratic equation x squared plus 2x plus 5 is equal to 0. That's not going to factor. So I'm going to, you can use the quadratic formula. Sometimes I like to just shake things up a little bit. Let's use completing
Your
the
conference
square.
is scheduled to end in 2 minutes.
So I'll start off by subtracting the 5 to the other side. B over 2 quantity squared, so that's going to be 2 over 2 is 1, squared is 1, so that's going to be x squared plus 2x plus 1 is equal to -5 plus 1. The factored form of this is going to be x plus 1 quantity squared is equal to a -4. Square root both sides. You get x is equal to, I'm going to go ahead and, again, for the sake of time, -1 plus or minus 2i. And there are my other zeros. So I did a couple of things at once. I took care of the square root of -4, that's 2i. I went ahead and subtracted the 1. So our zeros for this function are x equals 1, x equals 3, and x is equal to -1 plus or minus 2i. So, question to the person that asked about this. Did you include 0 for your x to the third?
No, sir, I didn't.
Yeah, that's what derailed you on that problem. That was it. Alright. Please, please, please make sure that you spend time watching
Your
the lecture
conference is now
videos
over. Goodbye.
for the next assignment. It will be a heavy day on Wednesday. Y'all have a wonderful day. I'll see y'all on Wednesday. Bye.